Hello. In this video, I am going to talk about some things to improve your graphing. I've called it graphing reminders because I think a lot of you actually already know some of this stuff, but I want to remind you about how to make awesome graphs because we do a ton of it in physical science. And for those of you that don't know about graphing, this will be a good introduction for you. So obviously we're going to be doing graphing on graph paper or on Excel or some other graphing software. It doesn't really matter to me which way you do it. It will be easiest for you to submit them if you do it on graphing software, but these things are still important and still apply because some of the graphing software doesn't actually do graphs appropriately according to how we want them done in science. So when we have graph paper, the one thing that we want to make sure of is that we have our axes drawn and drawn nice and neatly. So we draw the y-axis, we draw the x-axis. I missed the lines a little bit, so let me do that one again. This is why you always also want to do axes in pencil if you are drawing them by hand. That's closer. So now that we have our axes, the next thing we want to do is we want to know what's going on these axes. And so you need to make sure that you label your axes with both a title and unit. So let's say that this is a position time graph. So we're going to say that it is the time on the x-axis in seconds, and that it is the position in meters on the y-axis. Not only do we have to label the axes, but we also have to make sure that we number them and that we number them evenly. The two axes do not have to be numbered the same way, but they do have to have the same basic ideas behind them. Let's say we talk about numbering for 5 seconds. I'm going to draw my hash marks. And you'll notice that I'm not drawing a hash mark on every line. I like to make my graphs bigger so I can see more detail, and I would also like you to make your graphs bigger so you can see more detail. And as I said, I'm going to do, say that I have data for 5 seconds. So I'm then going to number my hash marks. When you number your axes, you can number every single point like this, or if you have a lot of them and they're not going to all fit in, you can number every other one. But if you decide you're going to number if you decide you're going to number the odds, make sure you number all of the odds. So you would want to make sure that you numbered 1, 3, and 5. Or you could decide that you wanted to number the evens. So you'd number 2, 4, or 6. It's up to you how you number them as long as you are consistent and that they are evenly spaced. By evenly spaced, I mean that each individual little square here on the graph paper is worth the same amount. So if you have to go over 2 squares to get to 1, that means every one box is worth half. So 1/2, 1, 1.5, 2, 2.5, etc. Excuse me. On the y-axis, we're doing position in meters. So let's say that we're going quite large distances here. So I'm going to say that maybe I want this to be 10 meters, and then 20, 30, 40, and we'll say that 50 is just fine. Okay. Same thing, evenly spaced, evenly numbered, and you don't have to do all of them if you don't want to, but don't ever just do the 10 or just the 50. You've got to do ones in between as well. Once we have that, we need to do our data. I am going to put some data on here so it creates a graph that is fairly close to a straight line. Not exactly, but fairly close to a straight line for the purposes of this demo. But our graphs are not always going to be straight lines. So when I put data on, I don't want to put a teeny tiny dot like that because I'm not going to be able to see it well enough. So online, and when you are doing this on the computer, you have options of changing the size of your fonts typically. So I can put a bigger dot there. Now that dot's actually a little bit too big because I'm not really sure where we're talking about. So sometimes you have to play around with this and say, all right, what about that? Oh, that's a better size dot. So I'm going to do one there. And this is, I'm going to assume, is data that I've taken. So some of it's not quite going to be in line. But that's close enough. So now I have my data graphed. I don't label my data points. That's not important in physics or physical science to label your data points. What you can see in the corner of the screen there is I'm just changing my pen back again to be thinner and easier to draw straight lines with. So I'm now going to draw what's called the best fit line. The line of best fit is not a dot-to-dot configuration. Instead, it is the curve or straight line that best fits the data. Now, I can tell by looking at this data that it's supposed to be a straight line with this center point here having something off of it. So I'm going to pretend that that center point doesn't exist when I make this line. So I'm going to start down here, and I'm going to draw a straight line. Again, try to be as straight as you can. Some graphing equipment or software rather allows you to make straight lines. Choose that instead of trying to do it freehand. But for a freehand line, that's not too bad. So again, I have my axes labeled. I have them evenly spaced and evenly numbered, both the x and y axis, with the quantity and the units. I have my data points drawn. I have a nice line of best fit on there. So now I need to come up with the equation of a line. Keep in mind that the equation of a line is generically y equals mx plus b. Remember, y is whatever your y-axis is. X stands for your x-axis. The m, remember, is the slope. Keep in mind that slope is change in y over change in x. Your change in y over a change in x, and your b is your y-intercept. Well, for this particular graph, I'm going to just continue my line down a little bit and say that pretend that the y-intercept is actually 0, so I don't have to worry about that. But finding my slope is important. I'm going to pick 2 points that are on the line, not necessarily 2 data points, but 2 points that are on the line. And here, this one's on the line, and that one's on the line. So my slope then is going to be from my y1 minus y2, so remember 50 minus 10, divided by my change in x, which is 5, and 1, so 5 minus 1. Oh, these came out really nice in terms of numbers. So 50 minus 10 is 40. 5 minus 1 is 4. So the slope of my line is 10. So what that means for the equation of my line is that generically in mathematics, you would write the equation of your line then to be y is equal to 10x. You don't have to put the plus 0 in there for the intercept. However, in science, we don't want that to be that generic. We want to be specific to the variables that we have on our graph. So on our graph, our y-axis is distance in meters, and our x-axis is time in seconds. So I'm going to put that into my equation. So y is distance in meters is equal to my slope of 10 times my x-axis, which is time in seconds. This here is the final equation of my line based on my data and my example. So all of these things are important to remember when you are making a graph for science. Make sure your axes are straight. Make sure they are labeled with the units and the quantity you're measuring. Make sure the numbers are evenly spaced and evenly numbered. Your data points need to be visible. Your line of best fit, if it's supposed to be a straight line, should be as straight as possible. And you have to come up with the equation of that line, and make sure when you write the equation of that line that it is written in terms of the specific quantities dealing with this example or with any example that you have. Hopefully this helps and will give you some extra guidance in activity 1.1. Bye.